In this lab, what I want to do is I want to talk a little bit about SQL injection, and I want to do a demo of how it actually works. And we're going to start by powering up our Ubuntu, and we're going to load a website that is vulnerable. So I'm just going to open up my Ubuntu machine. And in some of the previous labs, what we've already done is set up Apache and set up PHP. So we've got our web environment already to go. What I want to do is I want to connect up to a disk on the data store. So I've got an ISO image that already has our vulnerable website on it. So I'm just going to click on my CD, and I'm going to connect to an ISO image on a data store. And I'm going to connect to the website ISO. If you're not here, if I click my up arrow until I can't anymore, there's the t_ISO_image. I'm going to go inside this folder. And if I scroll down a little bit, I'll see an ethical hacking folder. If I go into that ethical hacking folder, at this point I see websites. And if I go in there, I see the website ISO. So I'm just going to mount this disk. And if I click on the little file manager, I should see a CD right here. And I've got the injection. So today we're going to be working on this injection lab. So I'm just going to grab up here and pull down so I can drag the injection out of the CD and onto my desktop. Then I'm just going to close this down. So this is the website. Now, right now it's tar.gz, which means it's compressed. The tarball is basically a zip file. So I'm going to actually decompress it using the terminal. So I'm going to go to my terminal window. And what I want to do from the terminal is I want to do a sudo, sudo. And the reason I'm going to be using sudo is because we're going to be writing to the var www folder, and in that folder we need to be an administrator to write there. So I'm going to use the tar command, tar, and then I'm going to add in a couple flags. So I'm using the dash, and I'm going to add in xvzf. So I always use that whenever I'm decompressing. X is to extract, Z is for zip, V is for verbose. Verbose just means you can see what's going on, and then F is for the file structure. So what I want to do is I need to path to this injection tar.gz. So I'm going to do a /, which means I'm starting at the root, and I'm hitting tab and I see home. So it's /home / student is my user. So I'm going to type in st, hit tab, and then it's on my desktop. So I need to do it with a capital D, DE tab. I see my desktop, and then I should be in to get to injection tab, and then I've got my injection.tar.gz. It's wrapping, but that's okay. I'm going to do a dash capital C, which means I want to copy the contents of this zip file to this location. So I'm going to do the /, and I want to go to the var www HTML. So I'm going to go var va tab, and then ww tab ht tab. So I think this should be good. So it's sudo tar, and then it's xzvf space, and then I just pathed to the injection by going home student desktop injection.tar.gzip space dash capital C space, and then the /var /www /htm. So when I'm hitting the tab and it auto-completes, that just gives me confidence knowing that I'm going to the right folders. If it doesn't auto-complete, sometimes that's a red flag that I missed something earlier. So I'm just going to hit enter here. It wants me to type in my password, which on this machine it's password. I'm going to hit enter, and it decompressed both the injection folder and the index.php. So what I want to do at this point is I just want to see if the website is up and going. So I'm going to just open up my Firefox. And I should be able to do my local host. /injection. Okay, so the first time this class was taught, all the virtual machines were running through a web browser. So the web browser would be where the entire virtual machine was hosted. In Blackboard, you would basically get a whole laundry list of machines, and you'd have to click on the right hyperlink to get your machine. So what I did is I created a website that was vulnerable in a couple different ways. So that way, one, it would make it easier for students to get their virtual machines or get access to the virtual machines. And then secondly, we could hack this in a couple different fashions. So after the first semester, the web-based virtual machines did not work at all. It was just a disaster. And what we ended up doing is installing vSphere on the machines, just how you're doing it today. But I thought the website still was valid, so I thought let's just make it into a project. So one point that I want to make with this website is it's a single factor authentication. Which means I just need to know one thing. I just need to know what the student ID is. If I know a student ID, then it would become easy to brute force this. The other thing that makes it easy to brute force is a student ID is 9 digits long. So student IDs usually start with 120 or 500, or they can start with 200. So there's a couple different formats. So if we're talking about the length of 9 digits, we're really talking about like 6. Because we already know the first 3. So if I wanted to brute force 6 digits, I could brute force probably every student ID in less than, 7 hours or something like that, just by writing a program that just enumerates through it. But that's one way that we could attack this website. But I really want to attack it using SQL injection. So if we type in a student ID that's a known student ID, and say get machines, we can see that it actually queried and returned a list of machines. Okay, so this is actually kind of cool. So it'll only return machines for students that you happen to know their student ID for. So it won't return a student that is unknown, but if you happen to know the student ID, then you can get a list of those machines back. So what's happening here is I'm printing out the SQL statement that's getting executed on the database. So the website is actually dynamically creating this SQL statement, and it's throwing it over to the database. The database will then process it and then return it. So what we're really focusing in here is on this where statement. So if we think about the way a database works, the database is similar to a spreadsheet in a way. You've got a table, and the table has columns and rows. And if I were just to look at this table here, if I were querying on a where statement, where machine name is equal to Windows XP, basically it would say select star from virtual machine where machine name is equal to Windows XP. So it would come and it would look at this first one, and it would say, well, is machine name equal to XP? And it would say, no, it's equal to Ubuntu. All right, so then it's false. And then it comes down to the next one. Is this Windows XP? And then no, it's 2003. And then it would come over here and it'd say, is this Windows XP? And then it would say, yes, this is Windows XP. So then it adds it to a record set that eventually gets returned back to whomever called it. So in this case, the PHP called it, so the record set would get returned back to the PHP. But it'll continue going down to the next one, is TigerBox equal to Windows XP, and it would be false. So it's either a true or a false. So if it's a true, it gets added to the record set. If it's a false, it doesn't get added. So that's the basic process of how this will work. So what we're going to do is we're really going to be exploiting the way the where clause works, and we're going to be taking advantage of the way that the programmer wrote the code for this website to confuse what is data and actually what is code. All right, so this is very similar to like the buffer overflow, where we're dynamically injecting code into a fill-in field. That's really what we're going to do. So let's say I didn't know any student ID. All right, so I just knew, garbage. I type anything in there, I get something back. So at this point, I'm selecting where student ID is equal to XXXXX. All right, so it doesn't know the student ID. There are no student IDs. No records are getting returned back. So I could sit here and brute force it that way. But what I want to do is I want to get a little creative. So if we take a look at the way that SQL works, the programmer made it so that way everything here that is black is static. All right, so they hard-coded the select from table where user ID is equal to. They even hard-coded in a single tick. Now everything that's red here, that's dynamic, so that's changing. Every time I type in a value, that number is being updated. So if I typed in, 777, all right, it's injecting that 777 in between the hard-coded single ticks. So the single ticks are hard-coded, but this value here is being added dynamically to the query, and then it throws that query over to the database, and then the database will return the records that it needs. So if I were to do the 1203 74050 number, I throw that, it threw this over to the database. The database went through all of its records, returned a record set that contained this. So this is what got added to the record set that got returned back to the web page. So what we're going to be doing is we're actually going to be messing with the SQL Server. So the way we're going to do it is, instead of writing a normal query, we're actually going to add a value that looks just like code. So now we're going to be confusing it a little bit. So everything that's red is what I'm going to be typing in. Everything that's black is still what the programmer hard-coded in. So we're not actually going to be changing the programmer's code, but we are going to be modifying the way that code executes by the data we're giving it. So the data we're giving it right here, that XX single tick space or space single tick 1 equals 1. So we're typing this in, and this is going to be the data that we're going to be passing to the query. Now the problem with it is this data sure does look a lot like code, and that's exactly what the SQL Server is going to be seeing. So by the time the SQL Server sees it, it's actually all black. So I mean, it doesn't know the difference between what's data and what's not data, just because the programmer basically hard-coded this query into a string, and we're just throwing the string over. So when the SQL Server gets it, it says, okay, find where the user ID is equal to XX, which all of them will fail. We already tried XX. There are no student ID XX. But on the flip side, it's got an OR, and it's saying OR is 1 equal to 1. So with the OR statement, the OR means that either one of these statements can be true, and it'll make the whole statement true. So if I look at this table, if I said, well, is machine name equal to XP? No, it's equal to Ubuntu, so that's false. But then it'd say, well, or is 1 equal to 1? Well, yeah, 1 is equal to 1. That's true. So the whole statement's true. So then Ubuntu gets added into the record set. Then the next one is the Windows 2003. Is that equal to XP? That's false. But there's the OR statement, 1 equals 1. Well, that's true, so the whole statement's true. So then it throws that record into the record set. So what we're basically doing is we're adding SQL to a data value, which now is confusing our SQL Server and making it think that this is actually SQL code instead of looking for a student ID. So let's just give that a try. If I come back over here and I do XX just to make sure, we get nothing. But if I do a single tick, now by adding that single tick, we're actually closing off the single tick, which is the beginning tick that the programmer has. So the programmer put a tick over here and put a tick over here and allowing us to type a data value. Well, we finished off the first tick, space, or space, single tick. And the reason that I'm doing that single tick over here is because we need to finish off the single tick on this side. If we're missing a tick, then we're just going to get an SQL error in general. It's going to say mismatched strings. So it's going to be equal 1 equals 1. And then I don't put the closing tick because the programmer hard-coded that closing tick for me. So if I make this red again, you can see that this is hard-coded, that's hard-coded. So all we're doing is doing these single ticks to match. So this one matches with that one. All right, so that's a matching pair. This one matches with that one, which is a matching pair, which leaves our OR not ticked at all, which makes it code. So now if I run this statement, XX single tick space OR space single tick 1 equals 1, get machines, now you can see it actually pulled back every single virtual machine. This is what's called an SQL injection. So this is an example, but some other examples are login forms. Those have been targeted for many years. And like if the username is admin, administrator, root, all right, so if you guess what the name is, and you don't know the password, people will try doing, well, the password's equal to XX or 1's equal to 1, just seeing if they can then log into the administrative account just by doing an SQL injection on the username. So the good thing is this is definitely able to be fixed. There's a lot of different possible fixes for it. The one that I actually prefer, there's a couple ways that you can do it. You can actually use what's called a parameter. By using parameters, you can basically put the variable up on the SQL Server, and then instead of passing in a string like this, you actually pass in the parameter, and then the parameter is filled up on the SQL Server. So that way, the SQL Server will automatically parse out what is not parameterized. So parameterized queries are definitely one way of doing it, and they work really well. And that's probably what the majority of people do, is do a parameterized query. So within either MySQL or Microsoft SQL Server, you can create stored procedures. Within stored procedures, you can have parameters. That's one way of doing it. If you're using PHP and you're using MySQL, you also have the ability to add parameters through the PDO connection. So the data connection will allow PDO, and PDO supports parameterized queries. Within ASP.NET, they also have inline parameterized queries. So any of those options are good. The other way that you can do it is you can do something called a regular expression. And what a regular expression will do will basically pull out anything that is not valid. Okay, so this is what I call whitelisting. You can whitelist and you can blacklist. So when this problem first arose, what people did is they blacklisted single ticks. All right, they said single ticks are no longer allowed. You cannot use a single tick. So if you had like Joe's Pizza, basically it would just remove the single tick. So if this is what I put into the fill-in form, what it would do is it would scan the string and it would see that single tick and it would just remove it. So if somebody tried doing this and it saw the single tick, it would just remove the single ticks, and now all of this is considered one string piece of data. So that was the original way that people tried to solve the problem. The problem is this was a cat and mouse game, so they blacklisted it. Well, people found really creative ways of getting around the single tick issue. They used hex numbers, they used extended ASCII characters, they used HTML codes. They just found different ways to create single ticks, and then the people that did the blacklisting started finding different ways of removing the single ticks. And during that early time, Apache got into the game. All right, so Apache said, boy, this seems like something that we could solve easily by just escaping out any single ticks. So what they did is they looked for a single tick, and if they found a single tick in the code, they just threw a / in front of it, and that / would then escape it so it wouldn't act like a single tick. It would act as a string, and then the SQL server or the MySQL server would work again. And they called that magic quotes. So within magic quotes, you could turn that on, and then magically your SQL injection won't happen anymore. Well, hackers found their way around magic quotes as well. And then Apache said, boy, this doesn't seem like this is our problem. So they deprecated magic quotes. They got into the game, they said, we'll fix it, and then after they realized this is a mess and people can still work around it, and they found that there's different database versions, different versions supported different extended ASCII characters, so they said, no way, we're not doing this anymore. Okay, so that's blacklisting. What I actually prefer is what's called whitelisting. Okay, so I use regular expressions to whitelist items. So if I know a student ID is 9 digits and only number, if somebody did something like this, what would happen using a regular expression is the regular expression would just pull out anything that does not match my pattern. All right, so it's a pattern matching language. So within this regular expression, I would basically get back 11. The regular expression would look at every one of these characters. X is not 0 through 9. X is not 0 through 9. Single tick's not 0 through 9. Space is not 0 through 9. 0, or the O, the R, the space, the single tick. Now this matches, 1 matches, so then it throws that over. Equals doesn't match, 1 matches, so that. So basically what you can do is if somebody throws in like a whole bunch of different data like this, and they tried to use this, basically my regular expression would take that and say, okay, not going to deal with the D, not going to deal with the A, the F, it'll take in the 7, it'll go up to the next 7, it'll go up to the 6, it'll go up to the 8, it'll take the 6, deal with the 8, deal with the 7, deal with the 8, 6, 8, 7. Okay, so now I'm starting to get close. 1, 2, 3, 4, 5, 6, 7, 8, 9. So actually, it would have just taken 1, 2, 3, 4, 5, 6, 7, 8, 9. It would have just taken this many, and then it would have stopped. It would have just taken that. So out of this whole string, everything after the first 9 digits, it would automatically just stop at that point. So that's whitelisting, and whitelisting is really a good solution because basically nobody can hack me if I'm giving them 9 numbers to hack me with. It's impossible because at this point they would need at least a pound, a tick. They'd need something more in order to do an SQL injection. So I'm a huge fan of whitelisting. That's typically what I do. Is I don't allow people to create usernames that have like single ticks, extended ASCII characters. If they're going to create a username, it's going to be basically A through Z, and I'll allow 0 through 9, and that's it. And then I'll use a regular expression to scrub it clean. So that's another way of doing it. Now, the last way of doing it's going to be the way that we're going to actually fix the SQL. there's something that's included with MySQL, and that's called the real escape string. So the real escape string is going to allow me to sanitize a string. So basically, MySQL says we know what we support for ticks, and if you throw me your string, I'll clean it up for you and give you back a valid string. So before I go any further here, I just want to take a screenshot. I'm going to go back onto my virtual machine. And I'm going to grab a screenshot of this. If I've got this, I definitely know that, that the SQL injection has happened. And now what I want to do is I want to fix the problem. So in order to fix the problem, I'm going to open up my terminal. And I need to open up the injection web page. So to open up the injection web page, I need to be a super user. So I'm going to do the sudo. I'm going to use gedit. And I'm going to open up the /var www ht, and then I want to get to the index, the injection, and then after the injection it's index.php. So I'm using gedit, and I'm going to open up var www html injection, and then finally index.php. So the password is going to be password. Okay, so this is a whole bunch of code, and I don't want you to get too overwhelmed with this. The code is just going to help us figure out how to fix the SQL injection. We've got quite a bit here, but we're just going to scroll down here a little bit. If you're a web student, some of this will be pretty familiar. So at this point, I can see I've got my connections happening. So I'm not all the way at the bottom, but I'm pretty close to the bottom here. And I can see a connection line. I see a line that says if it's dead, print out that you could not connect. I'm just going to put a couple lines here, some blank lines, so that way we can see a little bit easier. Right here, we've got our connection happening, and it looks like we've got our student ID that is being concatenated. So if you look right here, this is where we're selecting from virtual machine where student ID is equal to our variable. All right, so this is what I would consider to be, a vulnerable SQL statement. So we're just throwing a variable right inside the SQL statement. So everything that's purple on this line is hard-coded, and everything that's teal is dynamic. So we're not going to go too deep into rewriting this, but what I'm going to do is I'm just going to take this variable, I'm going to copy it, and I'm going to paste it. And I'm just going to make it equal to itself, and I'm going to put a semicolon at the end. So if you're not a programmer, basically what happens is this code is going to execute starting from the top, working down. So this line will execute before this line executes. All right, just so you know, that's the order that it's going to go. And then we've got an equal sign here, which is an assignment statement. Basically, the way an assignment statement works is anything on the right-hand side of the equation gets written over onto the left hand of the equation. So if I typed in XX for my student ID and clicked on go, basically they're both equal to XX. This is an XX, this is an XX. But what I'm doing, this line here is ending with the semicolon, is taking this XX and I'm overwriting this XX with this XX. So this line basically is not doing anything at this point. All right, so we're not really doing anything, but we're getting ready to fix the problem. So what I'm going to do is I'm going to do something called the real or the MySQL real escape string. So in order to call that method, the very first thing that has to happen is it has to be called after you connect it to your database. All right, so the connection has to happen first. That's why I picked this location. So right before the second student ID here, I'm just going to type in my SQL underscore, and then I'm going to type in real underscore escape underscore string opening paren, and then I'm going to put that student ID, and then I'm going to close the paren, and then I've got that semicolon. So if you take a look at this line, what's happening is we've got a method here that exists on the SQL server, on the MySQL server. So this method is going to allow us to throw a value into it. It's going to then go over to the server, do a bunch of work, clean it all up, and then it's going to take it and put it back into the old variable. So I've got what I consider to be a dirty variable, a variable that may have SQL injection in it. It's going to run through this process that's going to sanitize it. After cleaning it, sanitizing it, it's going to overwrite the dirty student ID with a sanitized student ID. Now student ID will be clean, so over here it'll be sanitized, over here it'll be sanitized. So just by adding this line, we've eliminated SQL injection from this application. So I'm going to grab a screenshot of this just to show the line that I added. So I'm just going to do my print screen, and I'm going to throw that print screen right here into this document. And then back on this screen, I'm just going to save the document. I'm going to hit the save button, and then I'm going to close this down. And I'm going to go back over to this statement, and I'm going to go back again, just hit my back arrow. So I've got an SQL statement. So this is our dirty value. When I click on Get Machines, it's going to sanitize it before it throws it over to the database server. So I'm going to click the button. So here's what it looks like. It actually threw the escapes in there and then threw it over to the database server. Database server said, I don't have any student ID that matches XX and then tick or tick 1 equals 1. So it's now using this whole value in here as a string. It's treating it as one string. So just by adding that one line, we actually eliminated the SQL injection from happening. So I'm going to grab a screenshot of this, and then I'm going to put that into my document that I'm going to submit. Okay, so that's SQL injection. We saw it, we took advantage of it, and we corrected it. So at the bottom of your document, I've got a request to type in a short paragraph describing the dangers of unchecked source code, which we've been kind of covering that, these last couple labs. And basically somebody needs to test for this stuff. That's the main point, is you need to have a pen tester that's actually looking at it. So when I test something, the first thing I always do is just throw in one single tick. When I throw in one single tick and it throws an error message, at that point in time, I know that it's vulnerable. I don't know necessarily if I can exploit it or if I can't exploit it, but if I throw in a single tick, it definitely will choke, and at that point I know that it's vulnerable. So I know some people have single ticks in their name, so they've been experienced this for years, and they now know every time they throw in that single tick and a page throws an error message when they're trying to save their profile, that just meant that that field that they filled in was vulnerable to SQL injection. Okay, so what could a hacker do with database access? Well, I just wanted to touch on the fact that some people are like, yay, it's just database, who cares, SQL injection can't be a big deal. It just blows me away when people make statements like that. Even if you're maybe not using all of the features of your database, it's important to keep in mind that databases have access to the entire system. So for example, Microsoft SQL Server by default comes with a whole bunch of stored procedures. Well, if somebody can write an SQL statement to take advantage of a stored procedure, they could use like a command that will allow them to access the terminal. So if I can get access to the terminal, I can use the net user and create a user and a password and add that user to an administrative account. So just by gaining access to the stored procedures that exist within a database, I can gain physical access to the machine, or actually remote access to the machine, by creating a remote user. But the other thing is, it's really important to remember your data is your business. If somebody drops all your customers, that's huge. You're going to have to recreate all of that data, and hopefully you've got good backups. But even worse, there's sabotage that's going on, but there's also espionage. People are actually trying to steal and snipe other people's accounts and users, and if they steal all of your customer information, now they've got a database that they can start to get a hold of customers and take advantage of that. And even worse, when you're talking about credit card data, usernames, passwords, it's going to give you a black eye, and you could even be held accountable if that data leaks out. So access to data is huge. So the other part of the question are what other areas that could be vulnerable to SQL injection. So everybody thinks of SQL injection, and they think of having a fill-in field like this where 1 is equal to 1. That is one area, but that's only one area. So if you go to certain websites, and I know Google obviously isn't vulnerable to it because they've got a lot of really smart programmers working on stuff. But previously I talked a little bit about the get versus the post method, and these query strings here. This data, SSL, is at some point being inserted into a database, updated from a database. So we've got that value where, it could be vulnerable. Obviously I wouldn't want to do an or, 1 equals 1. That wouldn't make sense. But at this point, people can do insert statements, they can do update statements, they can do delete statements, they can do drop, they can do creates. So there's a lot of SQL that can get added here. So some people will run SQL injection to create new users in tables so they can get accounts to websites that maybe they don't have access to. So we got to be careful. Now, it's not just gaining access through SQL injection, but we're gaining access to modify an SQL statement to make that SQL statement execute differently. You can also, on some SQL servers, do semicolons and then create a whole new SQL statement and then do like a drop and insert, Okay, so we've got parameters which exist within our query string up here. That could be susceptible. The other place to think about is if you think a little bit about how we modified the hidden data in some of the previous labs, the hidden tag is touching a database as well. So if you've got a hidden field on a web page, you could do an SQL injection on a hidden field that's normally not seen by posting that SQL up. So that's another place that could be susceptible to an SQL injection. So main thing is there's a lot of different areas that can be penetrated, and when you're doing a pen test for SQL injection, you want to see every piece of data that could possibly be touching your database. And if it's touching the database, you just got to make sure that it's not susceptible to an SQL injection. So anyways, hopefully this lab helps you understand what SQL injection is a little bit.